Okay, yeah, I think we are live. Uh, Welcome, guys. Good evening. Today, again, we will be studying time, speed, distance. We have already covered first part. My friend Vijay covered the first part of time, speed, distance, and I'm sure that you guys would have watched that session. Today, we will be covering further. We will be covering some more topics within this. If you guys are waiting, please join. We'll start now. Now, so before we start, I'd like to explain why we have break down TSD into two parts. Because first thing, it is a very important topic. Usually, we have seen that in many exams, this topic comes, and the questions are very conceptual. And to be honest, the topic is slightly lengthy. That's why we have break it down into two parts. In the first part, we covered very basic. We'll quickly go through the things that we have covered in the first part, and then we'll move on to the further topics. All right, so I think we can start now. Yeah, again, this is the schedule we are following. Today we have time, speed, distance. We'll cover this. We'll cover completely, I mean, all the major parts. Tomorrow we have progression and series. I mean, this is an important topic. I think that this is going to be I mean, there are going to be questions from this, because this has been an important topic in class 11th and 12th also. We have studied arithmetic progression and geometric progression also. So I think this is going to be tested in the exam, so I would suggest that you guys don't miss this topic. Further, we have linear equation part of algebra. You can cover that also. I would say that you join all the classes, all the sessions, because you don't have much time left, so you should not be missing out on any session. So yeah, this is the schedule. Tomorrow we have, as tomorrow is a weekend, we have Saturday, so the session will be between 3 p.m. to 4:30. You guys can join at this time. Similarly, on Sunday also we have the session on at the same time, 3 p.m. to 4:30 of linear equation. Yeah, this is very important. Guys, we have already launched 5 free mocks of IIMB UG program. These are all free for all the students. I would say that you guys should definitely be attempting all these mocks first, because you don't know what is the syllabus yet. So you should be better prepared. All these mocks are prepared considering what could be the potential topic or type of questions that can be tested. Second, you know that this is a 120 minutes of exam and it has 60 questions. So you need to get into the practice of sitting for 120 minutes, sitting for 2 hours fully focused. So you should be appearing for a few mocks and test and build your stamina for being focused for this long. So that's the same reason we have released the mocks. All the mocks are free, all the mocks are live. You should go there, attempt all the mocks before the exam. You should not be waiting for something. Even if your syllabus is pending, don't wait. Appear for the mock and see what is being tested, and then prepare your next course of action accordingly. Okay, we'll move on to next. One more important thing. At this time, a lot of you might be wondering, okay, where can I get all the updates? You should be relying on maybe some other channels, but we have a WhatsApp group. You can join that. You can find the same in the description box. You will get all the updates there. Should not be worried if you miss out on anything. Just join the group, and we put all the important updates there. Okay. Okay. I'll start now. Okay. This is something we have already covered in the first part. We covered all the basic thing. We'll recap. First thing, it's very simple. Yeah. Okay, so topic start with the formula. Formula is nothing but the relation between time, speed and distance. You would have studied that, okay, speed is equal to distance divided by time. Okay, Now, first thing I would like to recap here is there is a direct relation between speed and distance. What do I mean by direct relation? Basically, if you have a fixed time, if you are given that time is fixed, then the relation between speed and distance is directly proportional. If you increase the speed, your distance will increase. For example, I'll say my speed is, let's say, 5 meter per second, and the time you are given is 10 seconds. So your distance will be what? Distance will be 50 meters. Now you have the relation, the speed is 5 meter per second, your distance is 50, your time is 10 seconds. Now if you increase the speed, you increase the speed to 6 meter per second. Your time is same. So what will be your distance? Your distance will be 6 into 10, 60. This will become 60. You increase the speed, your time will increase, your distance will increase if your time is fixed. Similarly, you have another relation of speed and time. You have an inverse relation with speed and time. What do I mean by inverse relation? It simply means that if you increase the speed, your time will reduce if the distance is fixed. Again, let's take the same example. If we say that we have a speed of 5 meter per second, your distance is what, 50 meters, and your time is 10 seconds. Now let's assume that you have, this is 5 meter per second. Let me write it clearly, 5 meter per second. Distance is 50, time is 10. Now if you increase the speed, let's say if you increase the speed to 10 meter per second and your distance is fixed, what will be the time? Your time will be 50 meter divided by the new speed, that is 10 meter per second. This will be 5 seconds. That is, if you increase the speed, your time will be reduced. So there is a direct relation between speed and distance when time is fixed, and there is an inverse relation between speed and time when your distance is fixed. This is one of the basic concepts, but I think that you should you should understand this. Okay. Second thing, relative speed. You must would have studied in the last session that when two bodies move at the same time, then what is the actual relative speed between them? It is very simple. If they move towards each other, let's say this is body A, this is body B. This is moving at the speed of s1 meter per second, and another body, that is body B, moving at the rate of s2 meter per second. Now if they are moving towards each other, the relative speed will be the sum of both of their individual speeds. So relative speed will become s1 plus s2. Now on the other hand, if they are moving against each other, if they are moving towards each other, if they are moving towards the same direction, let's say A is here and B is here. B is moving to this direction, A is also moving to this direction. Against the speed of A is s1 meter per second, for B it is s2 meter per second. Now in this case, in the first case, when both are moving in the same direction, the relative speed will become the difference between their speed. We have put modulus because we don't know whose speed is higher. This is a simple concept of relative speed. Next we have average speed. You might understand the concept of average. It says that average speed is equal to total distance. Let me write it clearly. Total distance divided by total time. For example, you are somewhere here. This is, let's say, point A, and you are somewhere and there is some other point B. From this point, the difference between this point is 100 kilometer. Now from here, you are first going to this direction. it is taking you, let's say, 2 hours. And from this point you are also coming back, and while coming back, let's say you are taking 3 hours. So what is your average speed? First, you need to consider the total distance. Total distance is 100 kilometers you are going plus 100 kilometers you are coming back. So total distance is 200 divided by total time taken. While you were going, you took 2 hours. While you are coming, you took 3 hours. So this will be 200 divided by 5, which is 40 kilometer per hour. That is your average speed. Now, if you are not given the time, you are given the speed again, you can calculate the time and then find your average speed. Concept of train. Now, this is a very important concept and it is really tested multiple times. It basically says that you apply the concept of relative speed here. If two trains are crossing each other, let's say this is train A, this is the length, and there is train B, this is the length. If they are crossing each other, how much distance they are covering? They are covering the sum of their lengths. Because if A is here and B also need to pass this, so B first need to cover this distance as well as completely covering A, completely passing A, B also needs to cover its whole length, because when will we consider it is passed? When it has completely crossed. So this is B's distance, this is A's distance, or A's length and B's length. So this way, when they are passing towards each other, when they are crossing each other from opposite directions, so we have the total distance, that is length 1 plus length 2. Length 1, let's say this, and length 2, let's say this, the length of both of their trains, divided by their relative speed. Now in the in last few seconds only, we have studied like if the two bodies are moving towards each other, the relative speed will be sum of their speeds, that is S1 plus S2. Now if so this will be the time taken if they are crossing each other. If they are moving in the same direction, let's say A is going towards this and B also need to cross this. B need to cross this. Cross this, I mean need to completely pass over. Again, the distance they need to cover is same, it's just their relative speed will change. The relative speed again will be the difference between their speeds. If they are moving towards the same direction, that is, so their relative speed will be S1 minus S2, and the total time taken to completely cross each other will be, the distance will be L1 plus L2. L1, let's say the length of this train, the first train. L2, let's say the length of the second train, that is L2. Divided by their relative speed. The relative speed again is the difference between their speed. That is S1 minus S2. This will be the time taken to completely cross. Now, last topic, we'll revise this completely. And based on this only, we have the next topic. We have the concept of boats and streams. It basically says that if the boat is moving in the direction where the water is flowing, let's say water is flowing towards downside and boat is also moving towards downside, then nothing changes, it's just the relative speed will be what? This is, let's say, okay, this is river and this is the boat. Now river is also moving as well as boat is also moving. So the speed will be, the speed for boat will be what? The speed for boat will be the sum of boat's speed as well as river's speed, because river is also helping or increasing the speed. So in this case, relative speed will be speed of the boat plus speed of the river. And in against another case, when river is moving up but the boat is moving down, if they are moving against each other, then you understand that the relative speed will be less, because this speed of river, this is river and let's say this is boat. If river is, let's say, moving at the rate of 5 meters per second, and boat is moving at the rate of 10 meter per second. So let's say in 1 second, boat has covered what? 10 meter distance. But within the same second, river also covered 5 meters of distance, and it has covered in the against direction. So boat moved 10 meters down, but river has pushed it 5 meters up. So the effective distance is only 5 meter. And that is how you can understand the concept of relative speed here. The relative speed will be the difference of their speed, that is S1 minus S2 and modulus. Here it will be 10 meter per second minus 5 meter per second. So the relative speed or effective speed for boat will be 5 meter per second. This was the whole concept that you have already covered. We'll move on now. The next topic we have is escalators. Now you might think, okay, there is something new, but it is not, because it is just an extension or another version of boats and stream concept only. Let's understand this. Let's say if we have an escalator. Let's say this is the ground floor. This is the ground floor and this is the first floor. And there is an escalator. There is a person sitting here, not sitting but standing here. Now a person has to cover this escalator. Again, the person has two choices and the escalator is moving upwards. Now the person has two choices. The person can either just stand or he can also move upwards. Now if the person is only standing, then he will reach to the top with the speed of what? At that time only escalator is moving. So if the person is still, then he will reach to the top at the speed of escalator, or let's say the escalator speed is E. In escalator, you know that there is no meter or something, there are steps. So let's say escalator is moving at the rate of E steps per second. E steps per second. Or the person can have another choice also, that he can also start moving upwards. Now if the person is also moving and escalator is also moving, then the speed will be what? Speed will be the sum of both the speed of this person's speed and escalator speed. So speed will be person speed plus escalator speed. Now this is again the concept of same upstream and downstream. If the boat is moving up, let's say boat is moving up and the river is also moving up, the speed will be what? The relative speed will be sum of the boat speed plus sum of the stream speed. So this is the same concept, escalator. That is, if the person is moving in the direction of escalator, the speed of the escalator will be the speed at which the person will reach will be the sum of the speed of the person and the sum of the speed of escalator. And there is a opposite case also. That is, let's say the escalator is moving downwards at the rate of E steps per second, and there is a person here. He is moving upwards. The escalator is coming down, but the person is going up. In that case, let's say this escalator is moving at the rate of 5 meters per second down, and the person is trying to move up at the rate of 8 steps per second. Again, the concept, in every second the escalator is moving 5 down, the person is moving up. Effectively, they have covered only how much distance? They have covered 3 steps only. The person has covered only 3 steps. So this is the same concept of downstream and upstream, where the relative speed will be applicable to calculate the time taken to reach to the top or end point of the escalator. Now, one important concept here is that you need to understand the number of steps remain constant. Now, what do I mean by that? When you see an escalator, there is not a specific length which is decided. It is not calculated in meter or in any other unit. Basically, if you see an escalator, they are calculated based on steps, and those steps are fixed because the first floor and let's say the ground floor and the first floor, the difference between them is fixed. So number of steps is also fixed. So for any escalator, the number of steps will remain same whenever you see them. The number of visible steps will be constant. So yeah, this is the first thing that you need to understand. The distance or the number of steps will remain constant. Second thing, yeah, it says that if a person takes m steps, let's say m is 100, when escalator is moving, the person takes 100 steps when escalator is moving and n steps when the escalator is stationary. Let's say n is 200. Why? Because when he is taking 100 steps when escalator is moving, in that case some steps are taken by the person, some steps are taken by the escalator. So that's why they are taking 100 steps, let's say. And n steps when escalator is stationary. If escalator is stationary, then all the steps are taken by the person only. It is not taken by the escalator. So that's why they have some more steps. So yeah, to the same height, then the speed of the escalator and speed of person will be what? N minus m, that is 200 minus 100 is to m, because in that case the person moved 100 steps and the escalator moves 100 steps. But in the second case, when there was only person moving, in that case there was only the person moving, so he has to cover all the steps. So basically it says that when escalator is also moving and person is also moving, the person has to take less steps, and when only escalator is moving, only person is moving, then the person has to take all the steps. You can find the relation between their speed of the ratios. Next we have, okay, again the same concept we have covered for downstream and upstream. We have escalator and person moving in the same direction. Now again, as we discussed, that the number of steps will remain the same. One second. Yeah, the number of steps will remain the same. Let's say the number of steps be n. Now if the escalator and person are moving in the same direction, escalator is moving up, the person is also moving up, then the speed will be what? The speed will be, the relative speed will be sum of both of their speeds, because escalator is also moving in the same direction, it is also taking some steps, and the person is also taking some steps, into time. This will be equal to total number of steps. You understand? Distance is equal to speed into time. Speed here is relative speed of person and the person and the escalator, and the time will remain constant. Now escalator and another case, when escalator and the person are moving in opposite direction. We just studied here, if the person is moving down, escalator is moving up, the relative speed will be the difference of their speed. Now it is not necessarily that the person's speed will always be higher. It could be possible that the person's speed is lower than the speed of the escalator, and if they are moving in opposite direction, the person can never reach to the top. Let's say if the escalator is moving 3 steps per second and the person is trying to reach down with only 2 steps per second. Now if escalator is taking 3 steps to go up, the person is taking only 2 steps, so every second the escalator will keep pushing the person backward, or it will not let the person go to the bottom or maybe go to the ground floor. Basically it is not necessarily, but understand that if the person has to go in opposite direction of the escalator, then speed of the person should be always higher. Then only he can make any positive he can cover the positive distance. So yeah, same concept of downstream and upstream. In downstream, you have some of this relative speed is sum of the river and the boat. Here we have escalator and person. In opposite, we have again the negative effect, negative relative speed. Now, based on this only, we'll try to cover two questions. First says that a person walks up on a moving escalator at a rate of 5 steps per second. Let's say the person is trying to move up and he is taking 5 steps per second. And the escalator itself moves upward. So escalator is also moving upward and the escalator is moving at the rate of 2 steps per second. Now, if the escalator has 60 visible steps, remember the number of steps will remain constant. So number of steps are 60. Find the time taken by the man to reach the top. We know that the distance or total steps that are needed to be covered is 60. Divided by the speed. If both are moving in the same direction, the relative speed will be the sum of their speeds. That is 5 plus 2. This will be, let's say here, 60 divided by 7 seconds. So the person will reach to the top in 60 divided by 7 seconds. Yeah. And on the other hand, we have another case when a man walks up on an escalator at the rate of 5 steps per second. Let me check if it is visible. Yeah. So he's trying to go up with the rate of 5 steps per second. Let me write it clearly. Per second. This person is trying to go up while the escalator moves downward at 2 steps per second. Escalator is moving down at 2 steps per second. Now remember that the person's speed is higher, so it can cover positive distance even if the escalator is moving in the against direction. Now again, if the escalator has 60 steps, the steps are 60. For every second, person is moving 5 steps up. For every second, escalator is moving 2 steps down. So the effective or relative speed will be 5 minus 2, which is 3. So divide by their relative speed, which is 3 meter per second. Not meter per second, my bad, steps per second. If we divide, this will be 20. So the person will take 20 seconds to reach to the top. Yeah. So yeah, this was the concept of escalator. We'll move on now. If you don't have any doubt, we'll move on now. Okay. Yeah, the concept of circular tracks. This is one of now we will cover all the important types of questions that are asked based on circular tracks. We have basically 5 major types of questions. We'll cover them, and the good thing is there is a specific formula for each concept. If you understand the concept and remember the formula, it will be very easy for you to answer the question. First thing, we have circular tracks. Basically, if 2 or more people run on a track which is in the shape of circular, and the questions are asked based on this premise. Let's say we have this track, and this is, let's say, the starting point, and from this space there are 2 persons. Let's say the person is A and the person is B, and they are moving. The premise here is meeting for the first time. Okay, they are moving in the same direction. Let's say they are moving in this direction, both the persons, and their speed, let's say for A, the speed is 3 meters per second. For B, it is 1 meter per second. and the distance, the total length of this track is, let's say, 10 meters. Now how much time will it take for them to meet again when they are starting from, let's say, this point? How will they meet? If A has a speed of 3 meters per second, you clearly know that A will completely bypass B when they start the race, because let's say here we have A and B. A is moving 3 meters per second. So after 1 second, let's say A is here and B is only here, because B has covered only 1 meter. A has covered 3 meters. B has covered only 1 meter. So A is completely passing. So how can we say that when will they meet? For meeting them, the only option is A will have to cover his circle and then pass B. Then only A and B will meet. Or basically, if two persons are starting from one point and they are moving in same direction, then the faster person will clearly pass the slower person. Then for meeting them for the first time, the only possibility is the faster person has to cover the whole track and then reach or basically then pass the slower person. But how will they, what will be their speed now? Will their speed will be, let's say, what will be their relative speed? Now remember that if they are moving in the same direction, again the same concept, the relative speed will be the difference of their speed. For example, here only, A is here after 1 second, which is 3, and B is here only, which is 1. So after 1 second, A is 3 meters ahead and B is only 1 meter ahead. So the difference between them is only 2 meters. After another second, the difference will be again 2 meters. After another second, the difference will be 2 only. So this way, the person who is the faster person, here it is A, he has to cover the whole circle with the relative speed. And the relative speed here is the difference of their speed, because they are moving in same direction. So here we have the length of the track is what? 10 meters. 10 meters the faster person A has to cover with the relative speed. The relative speed is 3 minus 1. This will be 10 divided by 2, which is 5. So they will meet after 5 seconds for the first time if they are moving in the same direction. So this is the first concept, that is, if they start from the same point, and when will they meet for the first time? They will meet when the faster person covered the whole track with the relative speed. We have a question here based on the same only. Two runners A and B start together from the same point on a circular track of length 400 meters. So the length is, let's understand here. This is the track. The track is 400 meters. They start from they start from this point. A runs at the rate of 8 meters per second. B runs at the rate of 6 meters per second. After how much time will they meet for the first time? Remember, they are running in same direction. If they are running in the same direction for every second, the difference will increase by 2, because the difference of their speed is 8 minus 6. So their relative speed will be 2 meters per second. And again, A need to cover the whole track to reach to B to meet him for the first time. So A has to cover 400 meters with the relative speed, which is 2, and that is equal to 200 seconds. So A will be required 200 seconds, for A and B will together take 200 seconds to meet for the first time after they start. And the opposite or another case for the same is when both are moving in opposite directions. The second case is just another case when both are moving in opposite direction, and this is pretty logical. Let's say the same circle, here they are A and B, they are moving at the speed of 2 meters per second, and B is moving at the speed of 3 meter per second. The distance of or basically the length of the track is 10 meters. Now if they are moving in opposite direction, this person is moving here, this person is moving here. When will they meet? They will meet when both of them has covered some part of the whole track. Here somewhere, if you notice what from the starting point, A covered some part of the track and B covered other part of the same track. Or if I say, or in another sense, they both together has covered the length of the whole track to meet for the first time if they are moving in opposite direction. You understand that if let's say A and B are here and their both speeds are 2 meters per second. It is the same for B also. And the length of the track is, let's say, 12 meters. Then A is moving here, and B is moving here. If the speed is equal, they will meet exactly on the opposite side. So A will go from here to here and B will go from here to here to meet for the first time. And if you notice, they both have covered the whole length of the track. The whole length of the track, let's say, is 10 meters. And A has covered half of it and B has covered half of it. Together, for every second, both are covering some part of the track. After 1 second, A has covered 2 meters. B also has covered 2 meters. Then another second, A has covered another 2 meters. B also has covered another 2 meters. So if you notice, the relative speed will be sum of their speeds, because every second they both are covering the length of the tracks with the same rate. Similarly, and the same concept here is that if two persons are moving in opposite direction of the circular track, then they have to cover the length of the track with their relative speed. And the relative speed here is the sum of their speeds, because together they are covering the length of the track. Again, we have the question based on this. It says that if two runners A and B start from the same point on a circular track of length 400 meters, same, this is 400 meter. If A runs at the rate of 8 meter per second, B is running at the rate of 6 meter per second, and both are running in opposite direction. So every second A is running 8, B is running 6, and together they complete 400 meters. They will meet somewhere here. How do I know? It is pretty evident that A's speed is higher than B. So A will cover more distance than B. If their length is equal, if their speeds are equal, they will meet at exactly half point. But A's speed is higher. So A will cover more distance. So A will cross more. A will cross this half point. So they will meet somewhere here. Together they have covered 400 meters. A reached from this point, starting point, to this point. B reached from this point to this point. Together they covered 400 meters, and the relative speed and their relative speed is S1 plus S2, that is 8 plus 6, which is 400 divided by 14. This much time they will take to meet for the first time. So there was two concepts. First, when A is taking, if they are moving in opposite direction, in same direction, and the second concept, if they are moving in opposite direction. The only thing is we need to consider the relative speed, and in both cases they have to cover the length of the track. I hope this is clear. We'll move on to the next topic now. Okay. Now, this is one important question type. This is a specific question type that is asked, and it is mostly asked directly. It says that time to meet at the starting point. Time to meet at the starting point for the first time is the LCM of the time each person takes to complete one full round. Basically, the question says that, and it will ask you directly that if two persons are starting from this particular point, let's say A and B are starting. A and B are starting from this point. Now it says that after how much time will they meet at this point only. In the previous question, this condition was not there. In the previous question, it was like, when will they meet for the first time? It doesn't matter where will they meet. But this condition specifies that when will they meet at the starting point only. Now it is very logical, just understand the concept. Let's understand the two persons are running at different speeds. Let's say the length of the track is 24 meter. Or let's say this is 48 meter. Okay. A is running at the speed of 8 meter per second. Then if A starts from here, when will A come back here? When it will cover first round? How much time will A take to cover first round? A will take 48 divided by 8, that is 6 seconds. A will reach at the starting point at the 6th second, after 6 seconds. Again, if A starts, A will again reach at 12th second from the start. Again, A will reach at the starting point at the 18th second. So this way, after every 6 seconds, A will be here. Let's take another case. It is B here. Now B is running the same track. The length is 48 meters, and let's say the length of the speed of B is let's say 6 meters per second. So how much time will B take to reach at the starting point? He has to cover the whole track, that is 48 meter, with the speed of 6 meter per second. So B will reach at this point again after 8 seconds. This will be 8 seconds. Now again, for the second time, will B again reach here at the 16 seconds. And next, for the third time, I think it is not visible, or is it? Yeah, it is visible. And for the third time, B will reach. This is first time, this is second time. Third time, B will reach here at the 24 seconds. But we know that if B reached this point at 24 seconds, this same starting point, A will also reach after 18 seconds. A will also reach the same point at 24 seconds. It means at 24 seconds, both of them are at the same starting point. Now what do we infer this? We infer that the time they take to reach at the starting point, there will be some point, after some time, which is common for both, at what they will be at the starting point. A is at the starting point after covering 4 rounds and after 24 seconds. B is at the starting point after covering 3 rounds and after 24 seconds. And at the same time, both of them are at the starting point. And that is exactly what the question asked. The question asked after how much time they will reach at the starting point. But do we really need to do all the math to calculate at what point they will reach? We don't really need to. It's just, if you notice that A takes 6 seconds to reach at the starting point, B takes 8 seconds. Yeah, B take 8 seconds. Now what is the common time at which both of them are at the starting point? And for that we calculate the LCM. All we need to do is we just need to calculate the LCM of the time taken by both persons individually to arrive at a point which is common for both. So yeah, the time taken to reach at the starting point for the first time is equal to LCM. LCM of 6 and 8 is 24, which is common for which is a common multiple of both. So least common multiple of the time each person takes to complete the one full round. So this was the whole concept. You just calculate the time taken by both the person individually and then calculate their LCM. I hope this is clear. This is simple concept only. Yeah. Okay. This is the last concept. After that, we will do questions. And this is a direct formula based concept. You just need to understand a little. It says that if there is a circular track and if two persons are moving, they can be moving in the same direction or they can be also moving in opposite direction. So at what points on the track will they meet? We can specify that. We can actually identify at what specific points will those people meet. So we have two concepts. First, if they are moving in same direction, and second, if they are moving in opposite direction. Now understand this. It's pretty logical. Let's say, okay, let's say here we have a circle or circular track. The length of this track is 3 meters. And there is two persons A and B. A is moving at the rate of 1 meter per second and B is moving at the rate of 2 meters per second. Now, after 1 second, and basically the length of the track is just 3 meters. So let's say this is 1 meter, this is another 1 meter, and this is another 1 meter. So we have divided the track into 3 equal parts. Let's say this point is 0.1, 0.1. This point is 0.2 and this point is 0.3. Now after 1 second, where will A be? From here, A is covering 1 meter per second only. So from here till here, it is 1 meter. So A will be at 0.2 after 1 second. And where will be B after 1 second? B is covering 2 meters every second. So B first will cover 1 meter and then another meter, 2 meters. So B will be at P3 point after 1 second. So after 1 second, A is at P2, B is at P3. After another second, A is covering 1 meter per second only. So A will go from P2 to P3 after 1 second. So A will be at P3 and B will cover 2 meters. So from P3, B will go first 1 meter here and then another meter, P2. This is after second. Let's check one more. Let's go for one more step. After third second, from P3, A will come back to P1 after covering 1 meter. From P2, A will go 1 meter to P3 and then 1 meter to P1. So at this point, they will again are at the starting point. And this whole cycle will go on. Then next second, they will be at the same point, P2, P3. Then next second, they will be at P3 and P2. And then next second again, they will be at the starting point P1 and P1. Now what do you infer? You notice that in whole movement, they are meeting at only one point, and which is at the starting point. So this way we have understood that if two persons are moving in the same direction, so you first calculate their ratio of their speeds. Make sure that the ratio is in the simplified form or in the lowest form. And the number of points at which they will meet is the difference between their ratio. Let's say the speeds for two persons A and B is 10 meter per second and 25 meter per second. what is their ratio of their speeds, or in the simplest form it will be 2:5. And if they are moving in the same direction, then they will meet at the difference of their speeds at distinct points. The difference is 5 minus 2, which is 3. So on the whole track, if they move in the same direction, they will meet at 3 distinct points. Let's check the same concept with our previous question. Not previous question, but the example we understood. The ratio of their speeds was 1 and 2, and they were moving in the same direction. So the ratio of their speed is 1 and 2. So at how many distinct points will they meet? They will meet at 2 minus 1, which is 1 distinct point, and we clearly understood that they will meet again and again at P1. So whenever the people are moving in the same direction, just find out their speeds, convert that into the lowest form, and find the difference between them, and you will get at how many distinct points those two persons will meet when they are moving in the same direction. And opposite to this is the concept, that is, if they are moving in the same direction, if they are moving in the opposite direction, then let's say the ratio is S1 and S2 is 10 meter per second and 25 meter per second. The ratio will be 2:5. Then at how many distinct points will they meet? They will meet at 2 plus 5. So when they are moving in the same direction, you need to calculate the difference. When they are moving in the same direction, you need to calculate the difference. When they are moving in the opposite direction, you need to find the sum. So at 7 distinct points, they will meet on the track. Now let's do the same example that we did for the opposite direction. Let's do the same example that we did for the same direction. Let's do this for opposite direction and validate. Again, the track, the length is 3 meter. Let's say this is the starting point. This is 1 meter. 1 meter. This is another 1 meter. And this is another 1 meter. A and B are here. A is moving at the rate of 1 meter per second, and B is moving at the rate of 2 meter per second. So after 1 second, A will be where? From here, this is, let's say, P1, this is P2, and this is P3. So from here, after 1 second, A will cover 1 meter, so he will go here at P2, and B will cover 2 meters in the opposite direction, this direction. So 1 meter will be P1 to P3, and then again P2, because he is covering 2 meters, so he will at P2. So after 1 second, they are meeting at P2. Again, A will continue moving this side. So from P2, A will go to P3, because it is covering 1 meter per second. And B is moving in the opposite direction. So from P2, B will go to 1 meter here and then another meter here, P3. Again, they are meeting at P3. Let's check for the final lag. So A is at P3 after 2 seconds. A will come back to the starting point P1 after 1 second. B will also come back to the same point because B is at P3. So he need to go P3 to P2 and P2 to P1. Again, they both are at the starting point and they meet at all 3 points. Again, this cycle will go on. So as we understood, when they are moving in opposite direction, the distinct points at which they will meet only at these 3 points. So how did we found these 3 points? We calculated that the sum of the ratio of their speeds the ratio should be in simplified form. That is, we know that their speeds are 1 and 2, which are already in simplified form. So it will be 3. So when they are moving in opposite direction, they are meeting at 3 distinct points. And this was the whole concept. When they move in the same direction and their speeds are s1 and s2, the number of distinct meeting points on the track will be absolute difference between their simplified ratio. When they are moving in same direction, calculate the difference, and when they are moving in opposite direction, calculate the sum. This was the whole concept. First we studied escalator, then we did circular tracks. We'll move on to the questions now, and if you have any doubt, you can pin or message. So yeah, this was the first question. We have 2 minutes for the question. You can start the question. Okay, I think this was an easy question only, based on simple concept or initial concept of escalator we studied. It says that when ascending on an escalator, Ram requires 20 steps to reach to the summit. An escalator is moving, and on that Ram takes 20 steps. We don't know the speed of Ram, and we also don't know the speed of escalator. Let's say speed of Ram is r steps per second, and speed of escalator is equal to, let's say, e steps per second. Now we know that the number of steps in an escalator are constant. So Ram takes 20 steps to reach to the top. We know that n is equal to, that is number of steps is equal to speed into time. The speed here will be, since both of them are moving in the same direction, the speed will be the sum of their speeds, that is the sum of the speed of Ram plus the sum of the speed of escalator into time. How much time they are taking? We know that Ram is taking 20 steps and Ram's speed is r. So time is equal to distance divided by speed. Ram is covering 20 steps and the Ram's speed is r. This is equal to time. So time is equal to 20 by r. These are the number of steps. We have not done anything new, it's just distance is equal to speed into time. Another concept, another situation, whereas descending the same escalator, on the same escalator which is moving up, now Ram is moving down. Ram needs 40 steps to reach. Now escalator is moving up only, Ram is moving down. So the relative speed will be the difference of their speed. That is again n is equal to number of steps is equal to the sum of their speed, the relative speed here will be the difference because they both are moving in the opposite direction. And clearly if Ram takes 40 steps to reach down, it means Ram's speed is higher. So we can say r minus e into, again we don't know the time, but we know that Ram takes 40 steps and we know that the speed of Ram is 40 divided by r. R is the speed. So time taken will be 40 divided by r, that is 40 by r. Now we know that this whole equation is also equal to n, this whole equation is also equal to n. So we can compare both these equations. So we can say r plus e into 20 by r. This is equal to r minus e into 40 by r. Or basically we can say, we can cancel out r on the both side. We have 20r plus 20e is equal to 40r minus 40e. Taking both variable to the same side, so this will be 60e is equal to, this r will go here, so it will be 20r, or e by r is equal to 20 by 60, that is 1 by 3. So we got the relation between or ratio of the speed of escalator and speed of Ram. Now let's say what is asked. We are asked what is the ratio, the ratio would represent the Ram speed relative to the speed of escalator. That is, we are asked r is to e. We calculated r is to e. If you reciprocal this, you will get 3 is to 1. So answer has to be option D. This was a simple question. Let's move on to the next question. Okay. Yeah. Okay. This was again based on escalator. It says that Shama and Vyom walk up an escalator moving stairway. The escalator moves at a constant speed. We know that the escalator speed is always constant. Shama takes 3 steps for every 2 steps of Vyom. Basically, we are given the relation between the speed of Shama and Vyom. If Sham takes 3 steps, Vyom in the same time takes 2 steps. So basically, the ratio of the speed of Shama and Vyom is 3:2. Okay. Now Shama gets to the top of an escalator after having 25 steps. So Shama needs to walk 25 steps to reach to the top. Okay. On the other hand, Vyom, because Vyom is slow, takes only 20 steps. Okay. So Vyom takes 20 steps to reach the top. Okay. If the escalator were turned off, how many steps would they have to walk? Basically, if the escalator is not moving, then the person has to move the steps. So how many steps the person would need to cover? Okay. Basically, we need to find n, that is number of steps visible. Okay. Let's understand the concept of the equation for Shama first. Okay. Yeah. For Shama, we know that n, that is number of steps are always constant, is equal to speed into time. Let's say the speed of Shama is 3x and the same is for Vyom is 2x, because the relation of their speed is 3:2. So we have removed the ratio and we have considered a constant variable which is common to both, that is x. So Shama is moving at the rate of 3 steps per second and Vyom is also moving at the rate of 2 steps per second. So, and we can consider let the speed of escalator, let's say e steps per second. So n is equal to speed into time. Speed in Shama's case is what? Speed of Sham, that is 3x, and both are moving towards the same direction. So the relative speed will be sum. We are given that walk up on the same, and we are given, yeah, they both are moving in the same direction. Yeah, they both are moving up. So the relative speed will be sum of their speed, that is 3x, plus this is the speed of Sham. We also need to consider the speed of escalator, that is e, into time taken. How much time they have taken, or basically how much time Shama has taken to reach to the top. We know that Shama has taken 25 steps. So he has taken 25 steps. Distance divided by speed is equal to time. We know that distance is 25 and speed is 3x, because he is covering 3 steps per second. So this is equal to time into speed, and this is equal to number of steps. Let's do the same for Vyom also. Again, Vyom n is equal to speed into time. The speed of Vyom is what? 2x plus the speed of escalator, because both are moving on the moving escalator. So the relative speed is sum of the speeds into again time. The time in Vyom's case is, Vyom is covering 20 steps at the speed of 2x steps per second. So this is the second equation. We know that this is equal to the number of steps and this is also equal to number of steps. So we can equate both of these equations. So let's say Okay. Yeah. So we have 3x plus e into 25 by 3x. This is equal to, this is the total number of steps and this is also total number of steps. So this will be 2x plus e into 20 by 2x. We can cancel out x on both sides. This will be 10. Let's multiply to the inside. So 25 into 3. This will be 25x plus 25e divided by 3 equal to 10 into 2, 20x plus 10 into e, 10e. We can take the common variable here. So this will be 5x is equal to 10e minus 25 by e divided by 3, or this will be 30e minus 25e divided by 3, or we can say 5x is equal to, this will be 5e divided by 3. 5 and 5 can cancel out. So 3x will be equal to e. This is one relation we have got. Now let's check what we are asked. We are asked if the escalator was turned off, how many steps would the person has to take, or basically what is the number of steps. We know that n is equal to this and n is also equal to this. You can put 3x or you can replace the value of e in any of the equation. You can get your answer. Let's put it in first equation, that is n is equal to 3x plus, we can replace e with 3x into 25 by 3x. Now this is equal to 6x into 25 divided by 3x, or this can cancel out 2. 25 into 2 is 50. So there are 50 steps on the this escalator, or you can clearly see 50 steps, the number of constant steps. So answer has to be option B. Let's move on to the next question. Yeah, this is a very easy question. I hope that many of you are able to solve this. You just need to understand basic logic. Yeah. Okay. I think that many of you were able to solve this. It's just you need to understand one relation. Okay. It says that there are two persons are climbing up on two moving escalators which have 120 steps. So both the escalators have 120 steps. Let's say the escalator 1 and escalator 2. It has 120 steps and another escalator also has 120 steps. Okay. Now the ratio of the first person speed to that of first escalator, that is, let's say first person is P1, ratio escalator 1's speed, let's say the speed of the escalator 1 is E1 only, E1. This is given as 2:3 steps. Similarly, the ratio of the second person speed to that of second escalator is 3:5. So let's say second person is P2 is to the speed of the second escalator is, let's say, E2. This is given as 3:5. Now we need to find the total number of steps they both have taken together. The total number of steps P1 has taken and the total number of steps P2 has taken. Now if you notice, before in the beginning only we studied one thing, that the relation of the speed and distance is proportional. That is, the ratio of the speeds is equal to the ratio of their distance. Two persons who, let's say there are two persons, A and B. A's speed is 10 meter per second. B's speed is 20 meter per second. And if the time is fixed, let's say time is 2 seconds. So A will cover 20 meters in 2 seconds, B will cover 40 meters in 2 seconds. If you calculate the ratio of this, that is 1:2, that is again equal to the ratio of their speeds. All I mean is that if the time is fixed, the ratio of two persons, the ratio of the speed of the two persons is equal to the ratio of their distance covering. In first case, the total steps need to be covered by P1 and E1 is 120. In that, P1 is covering 2 parts and E1 is covering 3 parts. Let's say P1 is covering 2x, so E1 is covering 3x. In total they are covering 120 steps, so this will be 2x plus 3x is equal to 5x, is equal to 120, and 5x is equal to 120. With this we can find x is equal to 24. If we put x here, this will be 48 and this will be 72. If the ratio of speed is this, the distance will also have the same ratio. So in first case, P1 has covered 48 steps. Similarly, for the second case, let's say the speed is 3y and 5y. So they have to cover in total 120 steps. So 3y plus 5y is equal to 120, or 8y is equal to 120, or we can say y is equal to 15. Putting y here and here, so P2 is covering 45 steps and escalator 2 is covering 75 steps. We were asked, find the total steps they both have taken together. P1 has taken 48, P2 has taken 45 steps. So in total they have taken 93 steps together. So the answer has to be option B. You are not required to apply the complete logic of escalator. All you need to understand the logic is the ratio of the speed is equal to the ratio of the distance. And that's exactly what we have done. Okay, let's move on to the next question. Okay, this is the last question on escalator. After that, we will move on to the questions based on circular tracks. Okay, yeah, timer. Okay, yeah. I think this was slightly on the harder side. Not exactly harder, but there was one thing only that you need to understand, and that is very conceptual. Just need to understand half part is moving in half part the person is not moving, and in another half person is moving in against direction. But that would not really matter if you understand, if you have understood the concept. Understand that if the person is not moving and if the person is standing still, then only escalator is moving. So at that point the speed of the person will be equal to the speed of escalator only, because the person is not moving, only escalator is moving. So in this case it says that as an escalator in a mall functions at a constant speed. All right, a person standing still on the escalator will reach from the ground floor to the top floor in 80 seconds. The person is still, only escalator is moving. Now we know that n is equal to speed into time. Here the time is 80 seconds. What is the speed? The speed will be of escalator. Let's say the speed of the escalator is escalator's speed is equal to E steps per second. So n, that is number of steps, total number of steps, is equal to speed into time. The speed here is E and time is 80. So there are total 80 E steps on that escalator. Okay. Now Ram stepped on the escalator to reach the first floor from the ground floor. Escalator was moving up, Ram is also trying to move up. Okay. He was standing still till half of the distance. We know that total distance is 80 E. Out of this, half of the distance will be 40 E, or let's do this. Total distance is 80 E. Half of this distance is 40 E. In this time, or for this distance, the person was standing still. So for this distance, Ram was standing still. So the speed till this point will be the speed of escalator only. Speed will be escalators only. So the time taken to reach the half point will be distance divided by speed. That will be time, so 40 seconds. So Ram will take 40 seconds to reach the half point. Okay. Now after this, after 40 seconds, or basically after covering half of the distance, he starts walking towards the ground floor. The escalator was moving up, but now Ram is trying to move towards downside or towards the ground floor. Due to this, Ram reached the first floor. Still he could not reach the ground floor and he reached to the first floor. It means that the speed of the Ram was lesser than the speed of the escalator. Then only, even though he was moving down, but he reached to the top because escalator speed was higher. And in this, so basically after half point he was trying to move towards the downside, escalator was moving up, and this way he reached to the top after 120 seconds. We know that out of those 120 seconds, for the first half he took 40 seconds. It means whatever he was doing, that was done in the second half of the distance and in 80 seconds. So for the second half of the distance, that is 40 E, this distance is covered at the relative speed. The person Ram was moving down, escalator was moving up, and Ram reached to the top. It means that escalator speed was higher. So we can say E minus R. This was the escalator, this was the effective speed. So this was the time, this was the speed. Sorry, this was the distance or number of steps. This was the speed. Distance divided by speed is equal to time. And for this, in total he took 120 seconds. 40 seconds he took to reach to the half point. So he would have taken the remaining time, that is 80 seconds. Now if you simplify this, or if you cancel this, this will be 2, or E divided by E minus R is equal to 2. If you cross multiply, you will get E is equal to 2E minus 2R, or 2R is equal to E. This is you have gotten. We need to find the ratio of the speed of the escalator to the ratio of the speed of R, that is E divided by R. We can find this here. We have 2R is equal to E, or we can say 2 divided by 1 is equal to E divided by R. So the ratio of the speed of the escalator to the ratio of the speed of ram is 2:1, which is option A. Okay, let's move on to the next question. Now the questions are based on the second part that we covered, that is circular tracks. Remember the formulas and the questions will be very easy. Okay. Okay. I hope that you would be able to do this using formula only. We have Rakesh and Ranjit run around a circular track in opposite direction. Always remember of this, because we have different formulas for different directions. If they are moving in same and opposite, that would really matter. With the speeds of 18 meter per second and 4 meter per second respectively. At how many different points on the circular track do Rakesh and Ranjit meet? We know that when they move in the opposite direction. So first we will calculate the ratio of their speeds. Ratio of speeds. This has to be in the simplest form. Second, we'll revise if they are moving in opposite direction. Let's say if they are moving in opposite direction, then the number of distinct points at which they will meet is the sum of their ratio, and if they are moving in same direction, then this will be difference s1 plus s2 and difference of their speed. In this case, they are moving in opposite direction. So we need to use the first logic. First, we'll find out the ratios. We have 18 meter per second and 4 meter per second. That is, if we convert this into simplest form, we have 9:2. This is the simplest form. After that, the sum of the this is in S1 and S2 are simplest form. Now we need to find the number of distinct points for opposite direction. It is the sum, that is 9 plus 2, which is equal to 11. So Rakesh and Ranjit will meet at 11 distinct points on the circular track if they are moving in opposite direction. So answer has to be option E. It was pretty simple and straightforward. Let's do the next question. Yeah. Okay. Again, this is based on the same concept, number of distinct points at which they will meet. We'll not waste a lot of time on this question. It says that the ratio of the speed of A and B moving around a circular track is 5:7. That we are already given in the simplest form. What is the ratio of the number of distinct points at which they meet when they are moving in opposite direction? So number of distinct points. Okay, number of distinct points when they are moving in opposite direction, and 2, the number of distinct points at which they meet when they are moving in the same direction. So opposite of this, number of distinct points at which they are moving in same direction. So we know that when we are given the ratio of their speeds in simplest form, the number of distinct points at which when they move in the same direction is sum of that ratio, that is 5 plus 7, and when they are moving in same direction, then in that case the number of distinct points will be the difference of that ratio, that is 5 minus 7. So this will be 12 divided by 5 minus 7, modulus will be 2. So this will be 6/1, or the ratio will be 6:1. So the answer in this case is option B. Let's move on to the next question. Yeah. Okay, this is again not completely based on circular tracks that we have studied today, but using the whole logic of time, speed, distance. It says that the distance covered by a runner running a circular track is 5 laps per hour. We don't know what is the distance of one whole lap. We don't know, but we know that that runner is running 5 laps of that particular track. Let's say the length of the track is let's say the length of the track is, you can assume anything, let's say it is 100x, and that runner is running 5 laps in 1 hour. So we can say what is the speed of that runner. He is running 5 times this length of the track in every hour. So 100x into 5 laps, that is 500x meter. Let's say this is in meter per hour. Okay. Now, another runner whose speed is twice the speed of the first runner. So let's say this is runner 1. Runner 2's speed is twice of the speed of the first runner. First runner is running 500x meter per hour. So runner 2 is running of runner R2. This is R1. This will be twice of this. That is 1000x meter per hour. Okay. And is running another circular track. So runner 2 is running another circular track, and the length of that track is 1.5 times the length of the first track. We assume that the length of the first track is 100x meter. So the length of the second track that runner 2 is running is L2. Let's say this is L1. L2 is 1.5 times of this. So 1.5 times of 100x. That is equal to 150x meter. This second runner is running this track, and second runner is running at the rate of 100x meter per hour. We are asked find the number of laps made by the runner in 1 hour. We know that runner 1 can cover this much distance in 1 hour. That is 1000x, and we know that one lap will be 150x meter. So how many such laps are there? We can simply divide it with 150x, because 1 laps is equal to 150x, and the runner 2 can run 100x laps, 100x meter per hour. So if we divide, x and x will cancel out, this will be cancel out, so this will be 20 divided by 3, or will be equal to 6.67. So in 1 hour runner 2 can run 6.67 laps of the second track. That is option number B. In all such cases, when you are not given the length, you can always assume. And the thing is, such questions are always relatable. You are given the length of the you are not given the length of the first track, but given that the second is 1.5 times of the first one. So you can always assume that okay, this is 100x and the second one is 150x and all. It will make your calculation and understanding of the question more smooth. Okay, yeah, this is the next question. It's a good question, simple question. I hope that you should be able to solve this. I hope that you were able to do this. It says that it's one of the concepts that we studied today only. It says that A and B are two friends who are running on a circular track of radius 70 meters. We are not given the length of the track. We are given just the radius. Okay. Both start from the same point but run in opposite directions. Okay. A runs at a speed of 18 meter per second. B runs at a speed of 4 meter per second. After how much time from the start they will meet for the first time? Now we know that when they are moving in opposite direction, all they need to do is they need to cover the length of the track with their relative speed. And whenever they are running in opposite direction, the relative speed is sum of their speeds. So first we'll calculate the length of the track. We are given the radius, and length of the track is nothing but the circumference of the circular track. Circumference is, I hope that this is very basic, so you would have known this. We can easily calculate this using 2 pi and r. We know that the value of pi is 22 by 7. So this is equal to 2 into 22 by 7 divided by radius. The radius of the track is, we are directly given 70. If we cancel, this will be 10, and if we multiply, the length of the track is 440 meter. Now we need to find the time taken. For time taken, we know that distance divided by speed is equal to time. The distance they need to cover is 440 meter, and the speed will be relative speed. If both of them are moving in opposite direction, the relative speed will be sum of the speeds, that is 18 meter per second plus 4 meter per second. So 18 plus 4 meter per second, or 440 meter divided by 22 meter per second. If we cancel, this will be 20 seconds. So they will take 20 seconds to meet for the first time after they start. So answer has to be option B. Okay. I think this is the last question. Yeah. Okay, let's do this. It says that two trains are of equal length. Okay, we are not given the length of the trains. Let's say the length of one train is L. So the length of both the trains will be 2L. Okay, let's say length of each train is L meter. Okay, the speed of one train is 50% more than the speed of the other one. Again, as we just discussed in, I think, last question, that whenever you are not given any such information, you can always assume. Let's say the speed of train 1. Let's say the speed of train 1 is, you can assume anything. Let's say it is 10x meter per second. So the speed of the train 2 is 50% more than this. So it will be 15 meter per second. Okay. Now we have, they will cross each other completely in 100 seconds if they move in opposite directions. We know that when they move in the opposite direction, first they need to cover the distance equal to the sum of their lengths. And the relative speed when they move in opposite direction will be equal to the sum of their speeds. So we can say that distance is the sum of their lengths, that is L plus L, and speed will be the relative speed, which is 10x plus 15x. This will be equal to distance divided by speed is equal to time, and we know that it is taking 100 seconds. Or we can say that 2L divided by 25x is equal to 100, or we can say 2L is equal to 100 into 25x, or we can say 2500x. This is the length of both the trains. Okay. Now what will be the time taken by the two trains if they cross each other if running in the same direction? Same concept. In first concept, it was like they are moving in opposite directions. So the relative speed in that case is sum of their speeds. In this case, they are moving in opposite directions. So in this case, second case, they are moving in same direction. So the speed in this case is the difference of their speeds. We know that the length, that is 2L divided by the relative speed, that is 15x minus 5x, because in this case the relative speed will be difference of their speed. This is equal to 2L divided by 5x. We know that 2L is equal to 2500x. Let's put this 2500x divided by 5x. We can cancel this and we can cancel this. So the total time will be 500 seconds. So the answer has to be 500 seconds, which is option D. Okay. Yeah, I think that was the last question. Again, we will iterate that don't underestimate mocks. Today is Friday, you have Saturday and Sunday, you have both the weekends. I would say that appear for the mocks, finish off the mocks, understand the pattern, see what kind of questions are coming, and then start studying those concepts. We are launching the whole course on YouTube only. You can watch the videos. If you like the videos, you can share among your friends. But more importantly, make sure that you prepare well. And for that, I would say that it is highly important that you appear for the mocks. All the mocks are free. You don't need to book any slot or something. Whenever you are available, you can take out time, appear for the mocks, and then prepare accordingly. With that note, we can end the session.